Hi, welcome to Math After Hours with Miss Austin. I'm a licensed math teacher here to help you with your math questions. And today we're looking at adding and subtracting rational expressions. That's right, we're talking about fractions. So, very exciting. Everyone loves fractions. So, here we go. Okay, when you're adding and subtracting fractions, you must have a common denominator. The denominator has to stay part of your answer. For example, you would never say that 1/10 plus 2/10 equals 3. The denominator is part of the answer. It should be 1/10 plus 2/10 equals 3/10. So that denominator, you can think of it as a common name. Like if you had 4 apples and 3 bananas, you wouldn't say you had 7 banapples. That wouldn't make any sense. You have to find a common name first, like fruit. You would say, I have 7 pieces of fruit. So that's what we're doing with fractions. Before we can add them, we have to get a common name or a common denominator. So if we look at part A, we have 5 over 6 plus 3 over 7. So we need a common denominator between 6 and 7. So we want the smallest number that both 6 and 7 will go into. And the smallest number that they both will go into is 42. So what we want to do is, I know 42 will be my denominator, but how do we get 42? Well, for 5 over 6, I'd have to multiply 6 by 7, right? 7 times 6 is 42. But whatever we do to the bottom, we have to do to the top. So I also have to multiply 5 by 7. Because 7 over 7 is 1, right? So we're not actually changing the value of 5 over 6. We're just changing what it looks like so we can add the two together. So now the top of this is 7 times 5, which is 35. Then we go to the second fraction. The bottom is 7, so in order for that to be 42, we'd have to multiply by 6. And whatever we do to the bottom, we have to do to the top. So we have 3 times 6, which is 18. So now we have 35 plus 18, which is 53 over 42, and that would be our answer. So when you have rational expressions, it's the same idea, we're just throwing some variables in there. So on this one, we have 2 over 9x minus 4x plus 1 over 6. So let's just focus on the denominators right now. We have 9x and we have 6. What is the smallest number that both 9 and 6 will go into? 18. So I need there to be an 18, that's the smallest number those two will go into, but because the 9 has an x attached to it, that also needs to be part of the common denominator. So I'm going to create my giant fraction here. 2 over 9x. In order for the bottom to become 18x, I had to multiply that by 2. And whatever we do to the bottom, we have to do to the top. So on the top, we have 2 times 2, which is 4. If we move on to the second fraction, we have 6 on the bottom, and I want 6 to become 18x. So we would need to multiply by 3 and an x. And we also have to multiply by 3x on the top. And this is where you need to be really careful, because 3x needs to be multiplied to 4x and the plus 1. In addition to that, this is subtraction. So I'm going to write this as minus 3x times 4x plus 1. The biggest mistake I see in class is that students forget to distribute the negative. And so if you write it this way, not having actually done that multiplication yet, it's easier to see that that negative needs to be distributed in. So on the top, we'll have 4, and then minus 3x times 4x is 12x squared. And then we would have negative 3x times 1, which is negative 3x, and that's all over 18x. On the top, you would combine terms if they were like terms, but in this case, we don't have any like terms, so this is our answer. Okay, going on to the next one. We have 4 over y plus 1 plus 3 over y minus 2. If you look at the denominators, they do not have anything in common. You might say, but they both have a y. That's true. You see a y in both of these denominators, but they are different factors. When you see a plus or a minus, that keeps things together. So you have a plus in between y and 1. So you have this y plus 1. Those numbers stay together. They cannot be separated. And same with the y minus 2. Those cannot be separated. And so that means these two factors have nothing in common. So if you have two denominators with nothing in common, then your least common denominator will be what you get when you just multiply them together. So the common denominator will just have to be y plus 1 times y minus 2. So this entire first fraction here, the bottom right now is just y plus 1. So I would need to multiply by y minus 2 in the bottom and in the top as well. So now we have 4 times y minus 2. The second fraction is missing the y plus 1, so we need to multiply by that on top and bottom as well. So then this becomes plus 3 times y plus 1. Technically, you have not added these fractions together until you simplify the top. So if you were to leave your answer like this is incorrect. So you need to make sure you simplify. So across the top, this will be 4y minus 8, and then plus 3y plus 3, all over y plus 1 times y minus 2. In the top of this fraction, we have terms that we can combine. We can combine the y terms as well as the constants. So 4y plus 3y gives me 7y, and negative 8 plus 3 is negative 5. So my answer is 7y minus 5 over y plus 1, y minus 2. Okay. Our last example is a very popular type of question. I give these to my students a lot, and you might see this on your homework as well. So we have three fractions. We have x plus 1 over x plus 2 plus x minus 1 over x minus 2 minus 2x squared minus x minus 5 over x squared minus 4. The key to this question is this right here. We have this x squared minus 4 in the denominator. This actually factors. This is a difference of squares. It factors to x plus 2, x minus 2. And if you look at the other two fractions, we have an x plus 2 and we have an x minus 2, which are both part of this denominator here. And that tells you that x plus 2, x minus 2 is going to be the common denominator. So this fraction will not have to change because we have that denominator already, but these other two will have to change. So if that's going to be my common denominator, I'm going to create my giant fraction down here. This first fraction has the x plus 2 on the bottom, but not the x minus 2. So we need to multiply by that on top and bottom. So we will get x minus 2 times x plus 1 in the top. The second fraction is missing the x plus 2 on the bottom, so we need to multiply by that on top and bottom, which means we'll have plus x minus 1 times x plus 2. Then this last fraction already had the denominator we needed, but this subtraction sign right here means we're subtracting this whole fraction. So I'm going to put a minus here and then parentheses around 2x squared minus x minus 5, so I remember to distribute it in. From here, it's just simplifying across the top. So if I start by multiplying these two together, x minus 2 times x plus 1 gives me x squared minus x minus 2. Okay. Then if I multiply these two together, x minus 1 times x plus 2, this gives me x squared plus x minus 2. And then all I need to do is distribute this negative in the last one, so we get minus 2x squared plus x plus 5. And we don't want to forget our denominator is still x plus 2, x minus 2. Okay. So if we look at the squared terms, we have a x squared, and a minus 2x squared. When we add these two together, they're both positive, we'll get a 2x squared, but then we're subtracting 2x squared, so all of our x squared terms cancel out here. We also have a negative x and a plus x. Those will cancel each other out. And so a lot of stuff cancels here. We are left with 1x, and then we have negative 2 and negative 2. That's negative 4 plus 5 is 1, and that's all over x plus 2, x minus 2. And that is our answer. Okay, and that is adding and subtracting rational expressions. I hope that was helpful to you. If you have any questions you would like me to do, please comment them below, and thank you for watching.